Hey guys, in this video we will be learning to apply Newton's law to solve problems in classical physics. But as we know, Newton gave 3 laws of motion which are the soul of classical mechanics. So which law are we exactly talking about? So let me clarify that we will be learning to apply Newton's second law because it is the real law of motion. The reason it is called the real law of motion is because both first and third law of motion can be derived by using second law of motion. But before we derive the other two laws, let us first state the Newton's second law of motion. Newton's second law of motion states that external force applied on an object is directly proportional to the time rate of change of momentum. Mathematically, it can be written as F is proportional to dp over dt. Removing the proportionality sign, we get a constant of proportionality k, which will be 1 in our case. Therefore, we have F equals dp over dt. We know momentum is given as product of mass times velocity. Therefore, we have F equals d by dt of mv. Since mass remains constant, we will be having F equals m dv over dt, and dv over dt we all know is acceleration. Therefore, we end up with F equals ma, which is the mathematical expression for Newton's second law. Now we are in the position to derive the first and the third law of motion using Newton's second law. To derive Newton's first law, we know external force is 0, therefore F will be equals to 0. Therefore, we will be having ma equals 0. We know mass of an object cannot be 0, therefore acceleration has to be 0. If acceleration is 0, we will be having v minus u equals 0, which leaves us with v equals u. That is, the final velocity is equals to the initial velocity. Therefore, we have established that if external force is 0, the body moves with uniform velocity. To derive the Newton's third law of motion, we will consider two objects A and B which are isolated from the environment. That is, external force on both these objects are 0, but they can interact mutually with each other. Therefore, net force can be written as sum of the forces they exert on each other. Since external force is 0, we will be having Fa plus Fb equals 0. We will therefore have Fa equals minus Fb. Therefore, we have established that if a body A exerts a force F on another body B, then B also exerts a force of minus F on A, which is Newton's third law of motion. Now that we have stated all the 3 laws of motion, we are in the position to apply Newton's second law to solve problems in physics. The first step is to decide the system we are interested in. System may be a particle, an object, or a collection of objects. In the figure, you can see a boy holding a load over his head. So we have two choices. Either we consider boy as the system or the block or the load as the system. Suppose we are interested in knowing the mechanics of the boy, so we choose boy as our system. Once we have decided the system, our next step is to identify the forces acting on our system. In our case, the first force is the force of gravity that is exerted by Earth on the boy, that is acting downwards. Next is the normal reaction offered by the floor that pushes the boy in the upward direction. The third force is exerted by the load that the boy is carrying over his head that pushes the boy in the downward direction. We have now identified all the forces that are being exerted on the boy. Our next step will be to make a free body diagram by representing the boy as a point and the forces as vectors acting on the boy, with this point as the common origin. The lengths of these arrows are a function of the magnitudes of forces, and these points and forces are collectively known as free body diagram. After making this free body diagram, we can easily write what we call as equations of motion. For an object in equilibrium, the equations of motion can be written by equating the x and the y component of the forces. In our case, these forces are collinear and we do not have any other component of the forces. Therefore, the net force on the boy can easily be calculated by subtracting the normal reaction offered by the floor by the sum of the weights of the boy and the load. This is the way to apply Newton's second law to solve any problem in classical mechanics. Try solving similar problems, and if you face any difficulty, I am ready to help you. You can ping me on Instagram. I will provide you the link to my Instagram in the description below. In the next video, we will be learning to apply these Newton's law when the bodies are in motion. So this was it for this video. I will see you in the next one. Till then, stay tuned. Thanks for watching.